You know, building an AI, it's not just about slinging code. It's really a journey, a kind of quest to create something that can learn, predict, and maybe most importantly, earn our trust. Today, we're going to follow that exact hero's journey from a total blank slate to a powerful tool that could literally change lives. So, let's get into it. And this quest, it starts with a massive question. I mean, a real life or death challenge that pushes technology to its absolute limits. How in the world do you teach a machine to see something that even a highly trained human eye might miss? How can it possibly learn to predict something as complex as cancer? Because, get this isn't some far-off science fiction dream. A recent study in 2024 showed this is happening right now. And this is what we're chasing today. In this explainer, we are going to break down exactly how a system can reach this incredible level of accuracy. This right here is our holy grail. Okay, so first things first. Every hero needs the right skills for the job, and an AI is no different. The very first step on this journey is choosing its fundamental design, its architecture. The best way to think about it is picking the right kind of brain for the mission ahead. And these brains, well, they're not one size fits all. They are super specialized. You wouldn't use a wrench to hammer a nail, right? Same idea here. For seeing patterns in images, you've got your convolutional neural networks, or CNNs. If you needed to understand sequences, like how we speak, you'd probably use an RNN. Need to generate totally new data? Again, is your go-to. And for really understanding deep context and meaning, the big one right now is the transformer. Each one has a very specific superpower for a very specific mission. So, we've picked our hero's brain. Now comes the best part of any story, the training montage. This is where our AI learns, it grows, it gets stronger. And it really all boils down to two key things: the data you feed it and how you actually measure if it's getting any good. Look, I know you've probably heard this a million times, but it is the absolute gospel in AI. Data is everything. It's the food, it's the fuel, it's the textbook, and AI is only going to be as smart, as unbiased, and as powerful as the data we give it. Quality and, this is the big one, balance are everything. And you want to see a perfect example? Check this out. A 2025 study on text-to-speech systems. They started with skewed, imbalanced data. The result? Kind of meh, 60% accuracy. But look what happened next. They didn't change the algorithm. All they did was balance the data to a clean 50-50 split. And boom, accuracy just shoots up to 85%. That's the power of a good diet. So 85% accuracy. Sounds pretty awesome, doesn't it? But hold on, what does that number really tell us? Just like a final grade on a report card, a single score can hide a lot. To really understand how well our AI is doing, we have to dig a little deeper and ask more specific questions about what it got right and, more importantly, what it got wrong. And this is where we have to talk about two key ideas: precision and recall. Think of it like this. Precision is all about correctness. Of all the times the AI said, yep, that's it, how often was it actually right? Recall, on the other hand, is about being thorough. Of all the positive cases that were actually out there, how many did our AI manage to find? For something like sorting recycling, high precision is great. But for detecting cancer, you need incredibly high recall. You'd much rather have a false alarm than miss a single case. You absolutely need both to build a system you can actually rely on. Okay, our hero is smart, it's well-trained. But you know how in every superhero movie they have to team up to beat the big boss? Well, it's kind of the same deal in AI. To get to that next level, to become truly super, sometimes you have to create a team-up of hybrid models. And this was the secret sauce from that cancer prediction study we've been talking about. It wasn't just one type of AI that got them there. No, it was a fusion. They combined old-school machine learning, more modern deep learning, and this cool thing called digital twin technology. By teaming them up, they built something way more powerful than any single one of them could be alone. And just look at the results. It's wild. Traditional machine learning on its own, pretty good, 97% accuracy. The more complex deep learning models, a little lower actually, just under 95%. But when they combine them into that hybrid system, bam! That's how they hit that spectacular 99.73%. One model was seeing patterns the other missed. It just goes to show you, the future isn't about one single approach. It's about clever collaboration. So, our AI hero is now a powerhouse. It's accurate, it's ready for the real world. But there is one final challenge. And honestly, It might just be the hardest one of all, getting us human beings to actually trust it. Because amazing accuracy doesn't mean much if we can't understand its decisions. And here's why that's so hard. We run into this classic black box problem with a lot of these advanced AI systems. They give us the right answer, which is great, but we have absolutely no idea how they got there. The internal logic is so complex that the reasoning behind it is a total mystery, sometimes even to the people who built it. And that leads to a really simple human question, doesn't it? I mean, think about it. If your doctor couldn't explain why they were recommending a risky surgery, would you do it? If a security system flags a major threat but can't tell you what it is, do you actually believe it? At the end of the day, trust requires understanding. Without it, even the smartest AI is just a tool we can't really control. And this isn't some abstract niche problem. This need for transparency, for explainability, is absolutely critical everywhere. In cybersecurity, you have to know where the threat is coming from. In a hospital, a doctor has to be able to justify a diagnosis to their patient. In a high-tech factory, you have to know why a machine is acting up to keep people safe. So what's the solution to the black box? Well, there's this whole fascinating field dedicated to it called explainable AI, or XAI for short. The idea isn't to make the AI dumber. It's to build new tools that act as a translator for us. They show us the logic, they highlight the important data, and they basically reveal the why behind the AI's answer. It's all about prying open that box. So we've come full circle. We've seen how to give an AI the right brain, how to train it, how to make it superpowered with a team up. But this whole journey really ends with a new beginning, and a question that's more about us. As we make AI smarter and smarter, what's our role? What's your role in making sure it also becomes wiser? That's the real final step in this hero's journey.